Hey there. So I'm Heather Beadle with the AASPI Research Consortium, and I'm going to talk for a few minutes about SHAP Summary Plots and hopefully explain them pretty clearly. So SHAP Summary Plots I find incredibly useful. These are the ones that I use most of the time, and they let you do a more global analysis. So they're really great to get that information to solve any misclassification issues that you think you may have in your machine learning algorithm. Okay, so there's a couple different ways we can look at these. So right now what I'm showing you is a very basic SHAP summary plot. Okay, so we've got our 6 different attributes that were put into the random forest model, and we've got our 3 different classifications. So in this case, blue is turbidite, pink is background, and the olive color is channel. And what you can notice is that there's different lengths of bars. So peak magnitude has the longest bar. Let me turn on my pointer because I always forget to. So it's got the longest bar here, okay? So it was one of the most important features or attributes in this classification scheme. But what you can also see is how much it mattered relatively for each different attribute. So you can see here that the peak magnitude, the blue bar is the longest, so that is for turbidites, and that tells you that peak magnitude was very important for turbidites. If we go down here to find the next longest blue bar, we've got peak frequency and GLCM homogeneity. And so these two were also the next important, so like the second and third important attribute for classifying the seismic facies as a turbidite. Coherent energy, the blue bar is small, so it wasn't quite as important. But then if we look over to the background shales, so these are classified as pink, we can look for the longest bar, so maybe coherent energy or peak magnitude are the longest pink bars for the background shale. And so these were the 2 most important attributes for classifying as a background shale. And then we could see, like for channel facies, that greenish color, the least important feature or attribute was the smallest bar, and so this is GLCM entropy. Okay, so this is one type of SHAP summary plot, but there are other types of SHAP summary plots that I'm going to go through next. And these, rather than summarizing all the features together, you're looking at a different plot for each seismic facies. Okay, so let me pull those up. So first we're going to look at the turbidite. All right, so you can see here this is the turbidite seismic facies. And what you'll see here is what's called a violin plot. So it's kind of got all the different points. And peak magnitude is at the top. So peak magnitude was the most important attribute for the classification of turbidites. Next most important feature was peak frequency, then GLCM homogeneity, coherent energy, GLCM entropy, blah, blah, blah. Okay, so that's the order of importance for turbidites. But also we can look at the colors in the violin plot, and you can see here that peak magnitude is blue on the left-hand side, pink or red on the right-hand side. All right, so what this means is that the color has to do with that particular feature or attribute value. So a high value of peak magnitude, so a red value, tended it towards having a higher SHAP value, increasing the probability that it's a turbidite. A bluer value, which is a lower value for peak magnitude, tended it towards not classifying it as a turbidite. Okay, so let me go through another one. Let's say GLCM entropy. Okay, GLCM entropy is the 5th one down, so it was the 5th most important attribute in this set of 6. We can see here that high values of GLCM entropy tended it to have a larger SHAP value, a positive SHAP value, so towards being classified as a turbidite, while blue values created more of a negative SHAP value, so tended it away from being classified as a turbidite. All right. So we can also look at, here we've got, so it'll put out 3 different ones because we had 3 facies. So now we've got our turbidite, our channel, and our background. And you'll notice that the order of importance of attribute is different for each one because some attributes matter more for different classes. And you get different shapes and different colors going on. So we can look at peak magnitudes. I already talked about that for turbidites. It is also the most important for classifying it as a channel, but is the fourth most important for classifying it as a background. And one of the things you may notice here is that for background shales, a positive value of peak magnitude gave it a negative SHAP value, so tended it away from being classified as a background shale. If we look at GLCM homogeneity, you could see it has different values for different importances for different seismic facies classifications. So it was the third most important for turbidites, the least important for classification as a channel, and it was the most important feature for background shale. And so in the case of the background shale, a red or high value of GLCM homogeneity gave it a positive SHAP value, so tended it towards increasing the probability that it's classified as background. Okay, so that's just a quick summary of them. I had to spend like hours staring at these to understand it. But once you kind of get what the plots are showing you, I find that it's a very intuitive tool, and I could just look and interpret them in seconds now. So these is kind of like a quick summary of my summary plots. But as you go through it, and as you go through the SHAP and you're thinking like critically about your answers that the machine learning model is giving you, you know, some of the things I like to ask myself is, do the most important attributes make geologic sense? Are we seeing unexpected patterns that need more investigation? Okay, let me dig into what attributes were most important there. Does it make sense to me? And so, yeah, so the way I kind of tried to think about this is that these summary plots are revealing kind of the model's worldview. So how it's seeing the importance of different attributes for different classifications. So as always, I'm Heather with the AASPI group at OU, and we've got a lot more information about SHAP up on our website. Thanks for listening.